Structure is a structural representation of a molecule where dots are used to represent electron positions around the atoms. Lines and dots represent covalent bonds between atoms. The purpose of drawing a Lewis dot structure is to identify the lone electron pairs in a molecule to help determine chemical formation. It's useful as it is a key element and tool in order to easily understanding and simplifying covalent bonds, how they work and how they are represented. Additionally, Lewis structures are very important for predicting geometry, polarity, and reactivity of inorganic and organic compounds. It is based on the concept of the octet rule, in which atoms share electrons so that each atom has 8 electrons in its outer shell. As an example, an oxygen atom has 6 electrons in its outer shell. In a Lewis structure, these 6 dots are arranged so that an atom has 2 lone pairs and 2 single electrons. The 2 pairs would be opposite each other around the O symbol, and the 2 single electrons would be on the other side of the atom opposite to each other. The octet rule for Lewis dot structure leads to the most stable molecular and atomic structure. However, there are always an exception, and in this case there are 3. The first exception is when there are an odd number of valence electrons. The second exception is when there are too many valence of electrons that result in an incomplete octet, and the most common exception is when there are expanded octets where the central atom in a Lewis structure has more than 8 electrons in its valence shell. In expanded octet, the central atom can have 10 electrons or
1. Find the total numbers of valence electrons. Step 2. Lay out the atoms with the least electronegative non-hydrogen element in the middle. Step 3. Determine the number of bonds in a molecule. Step 4. Choose a central atom. Step 5. Connect the atoms to the central atom with a straight line representing a bond between the two atoms. Step 6. Place electrons around the outside atoms. Step 7. Place the remaining electrons around the central atom. Step 8. Lastly, check your structure carefully that it has the right numbers of valence electrons and that all the atoms have full valence. Use a double bond. Check the center atom. If it does not have a full valence, it's usually 8 electrons, except for H. Move non-bonding pairs on an outer atom to make multiple bonds as triple covalent bonds occur when 4 or 6 electrons are shared between 2 atoms, and they are indicated in the Lewis structure by drawing 3 lines connecting one atom to another, the same way as in double bond.
Formal charge indicates the gain or loss of electrons when forming a covalent bond, and a dipole moment shows the charge difference and points to the more negative element. This means they are widely related because when losing or gaining an electron, negativity changes and the dipole changes with it.
First of all, we have to see how many electrons we have in each element. Here we have 4 elements of chlorine, and we have 7 electrons of valence in every one. So, in this case, you multiply 7 per 4, and you have 28, right? Okay, perfect. Here we have 1 carbon, that is 4. So here we have 4 multiplied by 1 equals 4, right? Here we have to add this 2, so it's 32, right? Here we have to put the carbon in the middle of it, okay? Then we have to add the chlorine in each side. This one, this is the second, third, and fourth. Well, to begin, carbon have 4 electrons. Here is 1, here is 2, here is the third one, and the fourth one. Now, it's easy this one, because chlorine have 7, so they are only missing 1. That is this, they have 1, 2, 3, 4, 5, 6, and 7, right? So here, this is a bond. So you erase this one, and you have this, okay? We have to do this process with every one of these. We have to add the other ones. Here we have 3, 4, 5, 6, 7. Also here 1, 2, 3, 4, 5, 6, 7. Also 1, 2, 3, 4, 5, 6, 7. In this case, we have to make these bonds. How do we do it? We erase, and we write another line. Erase this one, we have another line. Erase this one, we have another line. So in this case, carbon have 1, 2, 3, 4, 5, 6, 7, 8. Carbon already formed its octet. Now, chlorine. We have 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we have all the elements forming the octets. Yeah. We are here with our second example. First, we have one carbon, and this carbon have 4 electrons of valence. We have 4 right here. Now, oxygen, we have 1 oxygen and have 6. So, plus 6, right? And we have 2 chlorine, 2 plus 7 is 14, right? Here, we have 24. Now, how do we do this? First of all, we have to put the carbon in the middle, right? We have to put an oxygen here and the 2 chlorine, one in the top and one in the bottom. Okay, so we have to do the same. Carbon have 4. This one is 1, 2, 3, and 4. Okay? Now, in this case, chlorine is easy because we have 7 electrons. We are only missing 1. So we have 1, 2, 3, 4, 5, 6, 7. Here is the same. 1, 2, 3, 4, 5, 6, 7. Here we are forming a bond between these two. Now, these are complete. We have 8 electrons, and this one too. But now we have to do something with the oxygen. Oxygen has 6 electrons. For this, we have 2, 3, 4. Here, 1, 2, 3, 4, 5, 6. Here we have to make a bond between these two. In this case, we go this way. Here has for its electron. No, it's octet. Also this one. Also carbon. We have 1, 2, 3, 4, 5, 6, 7, 8. And oxygen has 1, 2, 3, 4, 5, 6. No. 1, 2, 3, 4, 5, 6, 7, 8.
In this example, we only chose 2 elements, meaning no matter what their electronegativity is, they would be put side by side. The formal charge of carbon would be -1, as it has 4 valence electrons, 3 bonding electrons, and 2 non-bonding electrons, which gives a result of -1. And oxygen has 6 valence electrons, 3 bonding electrons, and 2 non-bonding electrons, meaning its charge would be +1. For this example, there were 2 main ways to bond this. However, we chose to create a triple bond between carbon and sulfur and a normal bond between nitrogen and sulfur. The least electronegative element was carbon, so we put it in the middle. Sulfur would have a formal charge of +1 because it had 6 valence electrons, 3 bonding electrons, and 2 non-bonding electrons. Carbon would have a formal charge of 0 as it has 4 valence electrons, 4 bonding electrons, and 0 non-bonding electrons. And nitrogen would have a formal charge of -2 as it has 5 valence electrons, 1 bonded electron, and 6 non-bonding electrons. In this example, we only chose 2 elements, meaning no matter what their electronegativity is, they would be put side by side. The formal charge of carbon would be -1, as it has 4 valence electrons, 3 bonding electrons, and 2 non-bonding electrons, which gives a result of -1. And oxygen has 6 valence electrons, 3 bonding electrons, and 2 non-bonding electrons, meaning its charge would be +1.